Hi. This is the 20th problem. Suppose that the function from R to R is a continuous periodic function and T is the period of it. Let A belongs to R, then prove that for any positive integer n, this is to be proved. I want to do this by using mathematical induction. So let me take this as Sn. There are three cases we see in mathematical induction. For n is equal to 1, we prove that it is true, and we assume that it is true for n is equal to k, and by that we prove it is true for n is equal to k plus 1 also. Now let me take the first case, that is if n is equal to 1. Sn becomes integral a to a plus t f of x dx is equal to 1 integral a to a plus t f of x dx. You can see this is true. So Sn is true for n is equal to 1. Second case. Here in second case we assume that this Sn is true for n is equal to k. So our Sn becomes integral a to a plus kt f of x dx is equal to k of integral a to a plus t f of x dx. So this is our equation 1. Now third case. We have to prove that this is true for n is equal to k plus 1. If n is equal to k plus 1, our here a plus nt and if n is equal to k plus 1, integral a to a plus k plus 1 into t f of x dx becomes integral a to, this is split as a plus kt f of x dx plus integral a plus kt to a plus k plus 1 into t f of x dx. T is period. In question it is given. So I can write it like this. And in the next step for the second part of this integration, we have to take substitution method. So let us suppose take x as y plus kt. To remove kt term, I am assuming this x is equal to y plus kt. Differentiating both the terms, we get dx is equal to dy. And limits also are to be changed. If x is equal to a plus kt, how the value of y changes? Let us see. X is equal to a plus kt is taken here in this. So a plus kt becomes y plus kt. That is y is equal to a. And if suppose x is equal to, upper limit is a plus kt plus t is taken, kt plus t, then in this place I am taking all these terms here. So a plus kt plus t is equal to y plus kt. So kt terms cancel, and a plus t is y. That is y is equal to a plus t. So we can write this part as integral lower limit at place of a plus kt, we have to take a, and upper limit is taken as a plus t. And this function also becomes f of, in the place of x, we have to take y plus kt. And then dx is dy. And this y plus kt is, it is a constant term, so you can write it as f of y dy. And you can write it as integral a to a plus t f of x dx. So this part, this is the term should come here. So in substitution method, when we do, this result comes, that is kept in this step, that is equal to integral a to a plus kt f of x dx plus, in this place, integral a to a plus t f of x dx. So here, what did you notice? From equation 1, we can take integral a to a plus kt f of x dx as k of integral a to a plus t f of x dx. So that is taken in this step. That is integral a to a plus t, k term comes forward. So f of x dx plus integral a to a plus t f of x dx. So let us take them as a single term by taking k plus 1 of integral a to a plus t f of x dx. So, what are you observing? Here, Sn is true for n is equal to k plus 1. That's all.